Hello everyone. In this video, let's discuss how to solve the DFA minimization problem in theory of computation very easily. So here we will be using only 4 steps to solve this problem. Only 4 steps. So the first step is to write the transition table. Transition table. We will be using the diagram or the graph which has been given in the question to write the transition table. So the door represents the transition table, and here if you see 0 and 1 are the input strings which are used to move from one state to another state. So 0 is the one input and 1 is the another input. Now what are the states being used in the diagram? A, B, C, D, E. So A, B, C, D and E. So now let's fill the transition table. Here this arrow mark represents A is the initial state, and this 2 circle around the E state represent E is the final state. So we will represent the final state in the transition table using the star. Now if you see A, for 0 it is moving to B and for 1 it is moving to C. Now B, for 0 it is moving to B itself and for 1 it is moving to D. Now C for 0 it is moving to B, for 1 it is having the self loop, that is it is moving to C itself. Now D, if you see, for 0 it is moving to B, for 1 it is moving to E. Next, last one, E, for 0 it is moving to B, for 1 it is moving to C. Now we completed the first step, and let's start the second step. The second step is to find the equivalence. We will be starting with the 0 equivalence at the starting stage. So what we will be doing in the 0 equivalence means we will be separating the states which are on final state and final state. Here A, B, C, D. These 4 are the non-final states and E is the final state. So we will be separating the final and the non-final states. Now we will be checking the relationship among the grouped one. That here we have grouped A, B, C, D. So let's check the relationship in the 1 equivalence. If you see the 1 equivalence, here we will be checking the relationship among the A, B, C, D, because A, B, C, D are in the same group. First let's check for A and B. So A and B, for 0 they are moving to B, and for 1 they are moving to C and D. So if you see here, B is in the same group, for which using the 0 they are moving. For using 1, A is moving to 1 and B is moving to D. So C and D both are in this group itself. So you can conclude A and B are having the same relationship. Now let's check for A and C. So A and C, for 0 they are moving to B, which is in this group itself. For 1 they are moving to C, which is in this group itself. So you can conclude A and C will be having the same relationship. Now let's check for A and D. So A and D, if you check, for 0 both of them are moving to B, which is in this group itself, that is in the same group. Now if you check for 1, A is moving to C but D is moving to E. C is in this group, E is in this group. So both are in the different group. So you can conclude A and D are of the separate group. Now let's check whether D, which has been separated from this group, is having any relationship with E. For D and E, if you check for 0 they are moving to B, but for 1 D is moving to E, which is this group, and E is moving to C, which is in this group. So you can see that both are in the different group. So D and E are not having any relationship. Now let's check further. That is second equivalence, 2 equivalence. So in 2 equivalence, what we will be doing? We will be seeing the relationship among A, B, C. So if you take A and B, for 0 they are moving to B, which is in this group itself. For 1, A is moving to C, which is in this group, but B is moving to D, which is in the different group. So you can conclude that A and B are of the separate group. Now let's check A and C. So for 0, A is moving to B, A is moving to B, C is also moving to B, which is in this group only. For 1, A is moving to C, which is in this group, and C is moving to C, which is in this group itself. So you can conclude A and C are of the same group. Now let's see for the, now if you see B is separated, D has been separated from the previous step, E has been separated from previous step. Now B is separated now. So now let's search whether there is any relationship among B and D and B and E. So now let's start with B and D. So B for 0 it is moving to B, D for 0 it is moving to B, which is in this group only. Yes, it is perfect. For 1, B is moving to D, which is in the separate group, and D is moving to E, which is in the separate group. Both are in the separate group, so you can conclude there is no relationship among B and D. Now let's search for B and E. B for 0 it is moving to B itself, which is in this group, and for 0 E is moving to B, which is in this group. So fine. Now let's search for 1. B for 1 it is moving to D, which is in the separate group, and E for 1 which is moving to C, which is in this group. Both are in the separate group, so you can conclude there is no relationship among B and E also. Now let's see for the third equivalence. So you must go with the many more equivalence up to which this step will be same as the previous step. Now let's search for A and C, which are in the same group. A for 0 it is moving to B, and C for 0 it is moving to B. So both are in the same group. A for 1 it is moving to C, C for 1 it is moving to C. So C is in this group itself. For 0 they have moved to the same group element. For 1 also they have moved to the same group element. So you can conclude A and C are of the same group. B, D and E will be same from the previous step because there is no changes in the grouped elements. So you can conclude this is the final step, and now you can write the DFA minimized diagram. So in this minimized diagram, if you see 1, 2, 3, 4, there are only 4 steps. In the given DFA diagram, we had 5 steps. So it has minimized from the 5 step to 4 step. So now let's draw the diagram in the third step. If you want to draw the diagram, A and C will be of the one group, B will be another, D and E. Now if you see E is the final state, so you can round it up twice, and A is the initial state, so this will be the initial state. Now let's search for the transition. A for 0 it is moving to B, A for 0 it is moving to B, A for 1 it is moving to C. So self loop because C is in this group itself. Now B for 0 it is moving to B, that is self loop. For 1 it is moving to D, for 1 it is moving to D. Now C, if you see, for 0 it is moving to B, 0 it is moving to B, for 1 it is moving to C, as it was for the A. Now D for 0 it is moving to B, D for 1 it is moving to E. If you see for E, for 0 it is moving to B, next for 1 it is moving to C, so you can write like this, for 1 it is moving to C. Now you have constructed the minimized DFA diagram. So at the last step, you can write them in the table format like this. So here let's start from B. We will ignore the initial state A and let's write from B, C, D and E. Now here we will be starting from the initial state A, B, C, D, but we will be leaving the final state. Here we are leaving the initial state. In this side we will be leaving the final state. So write like this. Now if you see here, if you see the equivalence, A and C were grouped together. A and C were grouped together, so we will put a tick mark. A and C were grouped together, so we put the tick mark, and for all others you can put the cross mark or leave as it is. So this completes the problem on the DFA minimization which has been given in the question. So hope you understood the topic very easily. If you have any doubt regarding this topic, please do comment below. I will clarify it. And if you liked the video, please subscribe and support us. Thank you.